operating system video playlist. நம்ம இன்னைக்கு பார்க்க போறது memory management. ஒரு பேஜிங்கிற ஒரு கான்செப்ட் பற்றி ஏர்லியர் மெமரி மேனேஜ்மெண்ட்னா என்னன்னு நம்ம டிஸ்கஸ் பண்ணியிருக்கோம். ஸ்வாப்பிங் எப்படி ஒர்க் ஆகுதுங்கிறதையும் நம்ம டிஸ்கஸ் பண்ணியிருக்கோம். ஸோ இன்றைக்கி இந்த வீடியோவில் பேஜிங் பற்றி நம்ம டிஸ்கஸ் பண்ணலாம். ஸோ பேஜிங்னா என்ன அப்படின்னா, இட் இஸ் ஆல்சோ a memory management scheme that permits the physical address space of a process to be non-contiguous. That is, every address generated by the CPU is referred as logical addressங்கிறது உங்களுக்கு தெரியும். The address is seen by the memory unit is referred as a physical unit. So users think that their program is stored in a contiguous locations. They can be think that the memory is to be contiguous. It is actually stored in a non-contiguous spaces. That is, it is scattered in various locations. So this what it will be done in paging concept. So paging clears the separation of users view of memory and the physical memory. ஸோ இந்த வீடியோவில் பேஜிங் எப்படி வந்து யூசர்ஸ் எப்படி மெமரியை வியூ பண்ணுறாங்களோ, தென் ஃபிசிக்கலி ஹவு இட் இஸ் அலோகேட்டட் அப்படிங்கிற ஒரு கான்செப்ட் பற்றி தான் நம்ம இங்கே வீடியோவில் பார்க்க போகிறோம். ஃபர்ஸ்ட், divide the physical memory into fixed size blocks called frames, and similarly logical memoryயும் நம்ம என்ன பண்ணுறோம் அப்படின்னா into blocks of same size called pages னு டிஸ்கஸ் பண்ணுறோம். So physical memory is divided into frames, logical memory is divided into fixed size blocks called pages. So ஒரு ப்ராசஸ் எக்ஸிக்யூட் ஆகிறப்போ its pages are loaded into any available memory frames for backing up stores. ஒரு ப்ராசஸ் வந்து லோட் ஆகிறப்போ அதனுடைய pages it will be loaded into the frames. So this is the paging hardware. We can see the CPU generated the logical address. So the logical address is divided into two parts. One is a page number, another one is an offset. So the page number is to be an index for the page table. So the page table contains the base address of a frame. Base address of a frame where actually the pages can be stored in a physical memory. So once we got the base address, then it will be added into the offset. We generate the corresponding physical address. So that the logical address is mapped into physical address. So here the physical memory. So paging la first நம்ம physical memory frames நம்ம divide பண்றோம், then logical memory pages divide பண்றோம். So ஒரு CPU generate பண்ண logical address எப்படி வந்து ஒரு physical memoryல போய் ஸ்டோர் ஆகுது அப்படின்னு பார்க்குறப்போ we can perform the similar mapping. So logical address is mapped into physical address. We have to use the address translation scheme. That is, the CPU generated address is divided into two parts. One is a page number, another one is an offset. So the page number is then used as an index into a page table where it contains the base address of a physical memory, and then offset it is combined with the base address and it defines the physical memory address that is sent to the memory unit. So for a given logical address space 2 power m and page sizes 2 power n, the lower order bit m minus n defines the page number and higher order bit defines the page offset. So here is a paging model of a logical and physical memory. The logical memory consisting page 0, page 1, page 2 and page 3, 4 pages, and these 4 pages are having the reference to the base address. It is indicated by the page table. So the page 0 is located in the frame number 1. Similarly, page 1 is located into frame number 4. So here we can execute the real-time example. So here the page size is 4 and the offset is 2. N equal to 2. Here the page size is 4 and the physical memory address space is 32 bytes memory address. This example shows how the user's view of memory is mapped into the physical memory. So the logical memory is divided into 4 pages and the 4 pages contains, this is the index. So page 0 is located into frame number 5. Page 0 is having the base address frame number 5, and how the logical address 1 is mapped. இது எங்கே லொக்கேட் ஆகி இருக்குதுன்னு பார்க்குறோம் அப்படின்னா, here we can use some simple formula. Base address into page size plus index or else page offset. So this is the formula where we can convert the logical address into equivalent physical address. So logical address 1 is in page 0. So page 0 oda base address enna appadina 5 into page oda size vandu 4 plus logical address 1 oda index vandu 1. So we get 20 plus 1, that is equal to 21. So the physical memory address space at number 21 we got the same. So here logical address 12 is mapped into how? Logical address 12 is in the page number 0, 1, 2, 3. Page number 3. So page number 3 oda base address vandu 2. So 2 into 4 plus 12 oda offset vandu 0. So 8 plus 0 we got 8. And the logical address 12 is mapped into the physical address 8. So paging, it's a memory management scheme. It mapping the logical address into equivalent physical address. It's a mapping scheme also. So by using paging scheme, it avoids the problem of varying sized memory chunks and also avoids the external fragmentation, but it still suffers the problem of internal fragmentations. Internal fragmentations means within the memory size is limited, means we get very small number of free blocks. So paging also worked like a job scheduling scheme. When a process is to be executed, its size is expressed in pages. So every page needs one frame. Thus if a process contains n pages means we need some n frames. So if n frames are available, it is allocated to the available pages in this arraying process. For example, 14 free frame list. In the free frame list, it holding the arraying process. The 14 is allocated to page number 0 and it is added into the page table, updated into the page table. Similarly, 13 is put into the page number 1, 18 is page number 2 and 20 is page number 3. Whenever the process is executed, its pages are loaded into the available free frames as it is in the arraying order. Wherever the free frames are available, it will be allocated, otherwise it has to be wait. So the hardware implementation of the paging will be explained in the next video lecture. So we can see the implementation of page table and the different levels of page table in the next video lecture, and thank you.